Hello, I'm back. So for more of these problems, just because there's some other that are a little bit complicated. So we've done 1 through 4, which were fine, I think. The other ones I asked you to do here, I think I asked for 6, 7, and 8 for sure. So I'm just gonna talk a little bit about 7 specifically, just for 6 to mention. For 6, so you kind of get the point, I hope, from problem 3 on how to do it when there's 2 parts. But I need to talk a little bit more about this rational part here. But to do that, I'm just going to do number 7s with you. So number 7 is going to help you out for number 6. All right, so let's do number 7. Let's see if this works. So we have f of x is equal to 3x minus 1 divided by 2x squared plus 7. So now be careful. The fact that there's a top part, the top part can equal 0. Listen to me, it can equal 0. This one here is fine. It is fine because it's on the numerator. Whatever the numerator is, just think about it. It can be anything. You can divide 0 by a number. 0 divided by 5 is just 0, right? And so essentially that's the point. Like you can divide, you can have anything for the numerator, meaning that when you're finding your domain, you don't actually need to do anything about it. Whatever is on the numerator does not impact anything as to how you're going to be solving the problem to find a domain. The only thing we care about is denominator. Do you remember what the denominator cannot be? Cannot be 0. So this is what we got to go and figure out right now. How do we make this not 0? So we are getting pretty good at this, right? It's not that difficult. So we want 2x squared. I don't know where I can write 2x squared plus 7. This cannot equal 0. Actually, we're going to write it so that it's equal to 0 and so for it. I don't know if I can erase with this guy. Yes, I can. Okay. So we're going to go and find out how this is equal to 0, which you know how to do, don't you? Oh, we're pink now. So let's see. So we want to isolate our x squared. So x squared is going to be equal to minus 7 over 2. Is that possible? Is it possible to find a number that is squared to be negative? I hope your answer to that is no. It would also be impossible to take the square root of this. So it means, what it means is this never happens. Never equal to 0. Whatever you would input inside of x here, no matter what number it is, your entire denominator would always be a whole number. Not a whole number. It would always be a number that is non-zero. In this case, it's even going to be a positive number as a matter of fact, because x squared is always going to be positive. So essentially what it means is that this is fine for whatever x is. So whatever we put for x, the function is going to exist. So it means that your domain would be x is a real number. That's it. There's nothing to exclude from it because numerator can be anything, doesn't matter. Denominator is never equal to 0, means x can be anything. That's it. But there's some problems. So if I just quickly, I don't want to solve it for you. I want you to do it again. But for number 8, the denominator, I'm just going to write denominator, is 3x plus 5. Is this thing going to be equal to 0? It definitely is. Like you will find a value of x to make this 0. And in that case, you're going to have to exclude it from denominator. But just notice that, again, numerator, it can be anything. So we're not going to look at the numerator ever, ever. Only the denominator. So just keep that in mind, right? And then it's going to be the same for problem 11. You only care about your denominator. Yeah, so I wonder if I might be making a video for 11 and 12 because they're pretty complicated. They're not that bad, but it's like there's a lot here. So I just want you to have the solution. I think I might not make a video. I think I might make solutions only and just give you the solutions for it. But like, yeah, be careful because here, just to give you on the right track, so 12 minus x, this one here is under root, meaning that this inside it's going to have to be positive. And then for this one here, you won't be able to have a denominator equal to 0. So you're going to have to look for the intersection between those two things once you find it. So we'll see what it gives us. All right. See you later, guys. If I can exit this video, of course.